afternoon, everyone, and welcome to our very first VES-Artex Academy webinar of the new year. We're very happy that you're here joining us. Today, our webinar will be put on by Charlie Hoffman. He is a product owner at VES-Artex, and he will be presenting on data-driven heat stress management. Before we get started, just one quick housekeeping item. If you have any questions or comments during the presentation, please type them into the Q&A panel at the bottom of your screen, and Charlie will answer them at the end of the presentation. With that, I think we're good to go, and you can take it away, Charlie.
Hi, all right, great, thanks, Annie. Hi, everybody, and I appreciate everyone taking the time to have this discussion with me today. Today, I want to be, as Annie mentioned, talking about data-driven heat stress management information, as well as talk about how can we utilize the other sensors in our barns to really get information that we may or may not have had before to really make data-driven decisions. As Annie mentioned, I'm the product owner of Dairy Boss. I've been with the company for about 10 months now, and I live in New York State. So I'm really happy to be here today and really appreciate everyone willing to join today. So I want to open up really with the first question. And, really when we look at it, it's really, how do we make the most out of our cows' environment today? So it's always a big thing. It's always something that we strive to do better. We always say we want to find the information that we have for today to do or to have a better for tomorrow. And so really, when I look at this question, that's posed to us, really I see it as that we need to control and adapt to the changing environment conditions, and really how to keep the cow comfortable. So in the end, that's the end goal. That's what everyone's here for. And at the same time, that makes us more efficient as a company, makes us more profitable, makes the conditions for the cows much better as well. So again, most of what we do here at VES-Artex, and as well as all the producers out there, it's a question that comes up every day that we try to solve. So I'm going to dive into heat stress a little bit. I just want to keep this very high level because these are things that we can find on the internet, and some of you folks here may already know some of these things. So I just want to keep it really simple and just kind of dive into some of what the work is that we've done thus far relating to heat stress, and then kind of where we're going with it. So I'm just going to start with the symptoms. Really, it's, again, pretty simple what you would think, and what most people know is that it's a decreased feed intake. What that also becomes, in whether in correlation, decreased milk production. We can also see visual symptoms. So as THI increases, this becomes respiratory rates. So beats per minute go up. Again, we start to see this a little bit more in first lactation animals. Our higher producer animals as well will be more susceptible to heat stress, and especially at an earlier onset. This is also in the form of panting, and then we could see increased standing, as well as increased standing, in the decreased stall use. Again, which, how much can we tie this as well, with heat stress when it comes to lameness? And that's a whole other section in itself there. So ways to combat, they sound simple, but at the same time, we also know that, each facility or how things are set up, we all have our own constraints. And so really the idea, though, is, again, the idea is to have accessible water. There's times in the summertime, especially, where we reformulate the ration to increase nutrient density. Again, having a cooling system. So I listed here high pressure fogging and soakers. Again, high pressure fogging more likely going to be used in arid temperatures. Again, in New York, we don't see much of high pressure fogging, but soakers are pretty well throughout, the United States and really in a lot of places. So and then adequate shade, again, depending on your region, you may be more so limited to it. And then increased airflow and ventilator velocity. And the reason why I put this here in blue is because we have several individuals on our staff that it's their job, and really they take a really good pride in working with the producers and consultants out there to make sure that their clients are best served with the best possible ventilation strategy based on their climate and in the strategy for how they want to produce. I'm going to show here the heat abatement guide. So again, this is probably something that people have seen in maybe just slightly different iterations, but again, it just kind of sets the context for some of the things that we talk about in terms of what heat stress is, and how we're trying to go about to combat it, or at least find better ways to approach it. So again, we have more of the mild, so that's anywhere between, it used to be upwards of 70, but now I think it's more so 65 to 72 is more so that mild heat stress that we're occurring. And again, we look at the lactation of the animal, and different things of that nature also play into effect. The more moderate would be more 72 to 80. And then from there, we have the severe, which is 80 to 90. And then getting past that, when we have our extreme and lethal, again, we're probably not so much in the lethal, at least I have really seen it. But again, it's just, again, important to note this, and especially for, how we tie these into the system to look at, different ways to combat heat stress. And so, I just wanted to set the context. There's other information, other literature here, but I'm not going to get into that today. So I want to talk a little bit about what we're doing as it relates to heat stress in Dairy Boss, and how the first integration started. So this first integration we have right now is actually with Allflex. And so the idea that we're starting right now is to generate and collect the data for later proof of concepts. And so what I mean by that is that we have our barn environment metrics, so temperatures, THIs, different sensors and probes that will monitor pretty much every corner of the barn. And then we take what Allflex has. In this case, we're actually getting what's called the heavy breathing percent, and that's by group. So the idea is to study this correlation, or the pen heavy breathing, with those environmental metrics. So right now, that heavy breathing percent, that group heavy breathing percent is, if you will, an arbitrary number. And so what we need to do is, we need to put some meaning behind that, and use, whether it's data analytics or individuals on our team, to look at trends and to see, when we look at pens or we look at groups of animals, when we have that percent heavy breathing, what THI are we at, and what are the consistencies with that? And when we have those things, we can then tie and then hopefully make inferences to then take it to a next step for a further part of the integration, which I'll explain a little bit later. How we ventilate barns, cool barns, could either be at the group or even the building level. At least that's how we have things in Dairy Boss today. The controls are more set on a building level for the ventilation. So the next step with that as well is to then take or aggregate the pen heavy breathing to an overall barn heavy breathing, and see how we can control the barn more effectively, especially in those summer months. Your June to August, or depends on your climate, but maybe slightly different. And then the questions to answer, really, again, and I kind of alluded to it just before, but what constitutes that heavy breathing with what we have for THI. And then at the same time, some of the other sources of information that we're bringing in, whether that's milk production or dry matter intake, what does that also have to do with the barn environment? And I'll get more into that later with later integrations and things that we have coming down the pipeline. And then ultimately, when we look at that, once we study the information and we can make some kind of ties to what we're getting, can we actually use the cows themselves as that secondary modifier, that biofeedback, if you will? So, a lot of instances we could have these other modifiers, such as wind speed or different things that may have an impact or influx on what we have for our current ventilation strategy. And having the actual cow's response, again, looking at this as a intelligent barn piece, what does that look like, and can we actually control it through heavy breathing with Allflex? So that's some background on it. Now, this graph here that I'm showing, again, by the time the integration started later on in the summer, so of course by the time in which we had the data, it was unfortunately a little later for summer months, so it's kind of a bummer. But at the same time, you can look here at the actual metrics that we have. And so you can see here that we have the main temperature, so that's the actual barn temperature, which was hopefully we would expect to be warmer, at least in the winter time, than the outside temperature, which is the blue. And then you can see here, I have Pen 5 heavy breeding. So this is from a dairy in Wisconsin. And you can kind of see that there is a correlation between the heavy breeding, which is going to be your percent, which is on the right y-axis. And you can see where, again, as temperature goes up, heavy breathing goes up. And so again, this is just some basic information we're collecting. We do have a little ways to go. We're still on the ground floor, but again, knowing that we can make these inferences, and then with this is at least is promising for us to be able to then correlate this with THI, with the other barn environment metrics, then ultimately have the cow be the main mediator of this. And as you can see here, this is about a 3-month span of information. But again, you can quickly see the correlation of how, when temperature spikes, it increases, when the heavy breathing for that pen increases, and then vice versa when temperature goes down. So I actually wanted to show this as well, because there's some interesting inferences we can take away from this as well. So again, this is from a dairy in Wisconsin, and this is a 3-day history of heavy breathing as it relates to inside temperature. And the graph, when we look at this, inside temperature is the orange. So the orange bar in every cluster. And we're going to have the green, the purple, the brown, and the pink is the pens in which we have pen 5, 6, 7, and 8 respectively. And you can see from here, as the temperature does increase, we do have an increase in heavy breathing. So again, it's kind of what we expected. The other thing I wanted to point out, though, is that we can see that that is not always the case. And part of that has to do with also stocking density. And so that's another thing that we also have to keep into consideration, and is a really important part of this. Typically, let's say stocking density could be 20–30% more than what pens are allotted for. That's just common practice that we have today. And so how I see this is that we also have to keep that into consideration as we formulate the best design for this modifier for heavy breathing. And then the other thing I wanted to point out here is on the 18th here, from about 5:30 in the afternoon to, this would be a 5-hour difference, so let's say at this point a little after 10 o'clock on the 18th, we can actually see that temperature goes down, yet heavy breathing still remains rather high. And I think that also improves the fact that we all know, or people that understand or know a little bit about heat, heavy breathing, or heat stressing cows, that it's kind of a ramp up, and once they're at that level of heat stress, it takes a while for them to come down from that heat stress. So I think that that's what we're seeing there in terms of the differences between, although temperature goes down, we still actually in this case have a little bit of an increase. But then again, you could see temperatures kind of tailing off at the end here, and then which is again indicative of how that relates to, in this case at least, temperature. But again, we need to marry this more with THI, more importantly. So things to consider, some of it I actually alluded just before there, but again, with this data, it's great to see the current pen status, what the pen status was for the last couple of days, to see what that actually has effect on in terms of our heavy breathing. What is the stocking density of that pen at that time? And so the other thing that would be really, and where we'd like to be continually kind of doing research on this is, comparing the pens at different times, for example, and again, at the same time, where are like the colder areas of the barn, perhaps, what direction is the wind coming from, shadier areas. So let's say, areas where the sun, where the barns are in orientation to the sun. And again, those things will be important to know in terms of really, whether you have cow bunching or different things like that. I don't think it's so much a problem today, but we still see it. So, I'd be very curious to see kind of what these kind of connections, what we can do with, with some of these issues that we have today. So, and at the same time, we can also assess the current ventilation strategy that we have. with this heavy breeding value once we tie more meaning to it with the other barn environmental metrics we have. So again, it would be very curious to find, what we could, come from this, and maybe based on this, can we use this to help maybe improve our ventilation strategy, perhaps. So, and this also then dovetails into, the last question here that, and these aren't all of them, obviously, these are just some questions, but we look at this as, where do we have our fans? What type of fans do we have? Is our cow cooling adequate? Do we warrant the need to have high pressure fogging, for example? What kind of fans do we have? Do we have just, fans that maybe don't get air down, don't have the velocity at the cow level in the bed? And so again, I think that with this information that we collect and tie, we can actually answer more questions and find out more of, the proper ways in which we can kind of venture down this route to having a better cow environment overall. So, which then this kind of leads, so I want to also talk a little bit about how we're using sensors in other parts of the barn as well, and what that data looks like and what that could mean for the future as well. So again, it all starts with the animal well-being, and that's obvious. So, cows lay consistency, whether that's in their diet, whether that's being milked, whether that's in their environment. So, and again, that encourages, proper cow behavior, eating, resting. Can we get cows to lie down more? I think it's probably somewhere, I think, in between 6 and 8 hours today. And really, we want to get to that 12-hour mark, I believe it is. So, can we, through whether it's sensors, let's say in the barn, and proper ventilation strategy, can we increase that? Which then leads obviously to more efficient operations. Again, this being more of the intelligent part of barns. And so again, it's really just like anything else that we're used to in just regular consumer grade things today. We have a nest to control our house. We can basically do the same thing with an intelligent barn. Again, the power is at your fingertips when we take a more proactive rather than a reactive approach. And so again, this can lead to other things later on down here in terms of the environment and then the bottom line. And then again, the overall reason why we're here is to really improve the profitability, whether it's the dairymen or as well as, have profitable cows. Again, margins are pretty tight. And so, if we take a little bit in each sector, maybe that we can improve on, it could be feed, it could be the parlor, it could be the barn, and we find things that which we can improve on, all those little wins collectively could really make a big difference. And so when we talk here for today's purpose, in terms of the back of the barn and the sensors in which we have to control things, can we find these little wins to make us a little bit more profitable than we were yesterday? So I use this kind of headline here is take control of your barn. And so these sensors here that we have listed are just a few things that we have today. Some of them are a little bit more prominent in farms. Again, temp humidity we use a lot, whether that's to control ventilation, ammonia, whether that's for calves, especially in other applications. But, based on the data that we collect, what can we find from that and what can we learn from that? And so we then tie this, and it's also really important to tie this in obviously to weather data. So real-time weather data for that exact location. And then with that, being able, like I said, to have a system where you have easy accessibility, you can make that change now rather than later. So I know I got quite a few, things plotted here. So I want to go through this and explain the reason why I put this up here. Again, this is a week span. This is a farm in Wisconsin as well. And so again, what we want to see here is, one, what was the temperature humidity, but two, are we doing a good job? Are we staying consistent? The purple colors that you're seeing there are going to be your humidity. The red is going to be your temperature. And then the triangle pieces here is going to be your inside. So you got your inside, humidity, your inside temperature. And the point I'm trying to make here when you're looking at this is that you can see that, for example, you have your spikes in for example, your spikes in humidity here. And then you have your, again, same thing with temperature, more larger increases and decreases. And really what we see here is we do see fluctuation, in the inside of the barn, but we also are pretty consistent. And I think that that's really important to note, that even based on wild swings, that we're keeping pretty good in terms of whether that's percent humidity or temperature is staying rather consistent. And then again, it comes back to the whole part of being consistent for the cows and everything else. So again, using the sensor data to see, how good are we today? How good are we over a month? And then so forth. Same thing again with this, we could see here that, so this is just a standard just THI plot. This is inside and outside of the barn. We could see that inside the barn is a little bit higher. This is, I picked here from June, where it actually is more relevant. Obviously now it's not. So I went back in time, but again, the point with this is just to show that, hey, we do have the tools necessary to look at these trends. And I think that we do put a lot of emphasis in feed and put a lot of emphasis in milk, but the cows spend a lot of time, laying down or chewing their cud, or kind of socializing with one another in the pen. And so, I think we really need to kind of change also the way we look in terms of, what kind of information are we getting from the barn itself, and do we have enough today? This one is actually particularly interesting. So this is from a calf barn in Wisconsin, and you can see the freezing line. So with these reports, you can add in various things to help interpret the information. And this is plotted against temperature, and you see ammonia level in green. And the really interesting part, so this is for the month of February, as you can see up top there. And the interesting parts here is you can see every time ammonia spikes up, and then when it goes back down, you can actually see that these are actually the events in which they're actually changing out the bedding. So you can see where ammonia is highest, they haven't cleaned yet, and then they go and they change the bedded pack. And you can see the differences in which, they're doing that, and the occurrences, and the correlation with temperature. So again, it's tying those events that we have today with the sensors and metrics that we have. So again, it's using other sensors that we have in the barn to really help us make decisions, or see where we may be able to improve. This one I show, and I apologize, I have I'll explain where the words are kind of cut off here. But what I wanted to show in here again is, not only do we use it, the sensors that we have just for monitoring, the barn and getting, let's say, temperature related stuff, but we can also use it for the actual performance of the fans. And this later gets into, what we'd like to do in terms of, having a maintenance log. So, how we want to keep track of whether that's, service agreements, serial numbers, serviceability of the fans. And you can see here, so we have our group of fans. So this is actually a barn out in Idaho, and this is for the half the month of August. And the last bar, the pink bar, is temperature. And you can see that, again, this is just more so a monitoring aspect of, again, just the data in which you can look at, that you see that as the temperature increases, the RPMs of the fan increase as expected. They max out somewhere around 320, I think is the absolute full RPM speed of those fans. But you could see at around 65 degrees Fahrenheit, the fans will ramp up. And then the full speed is that's what's kind of hidden. So that's why I wanted to explain it. At 72 degrees Fahrenheit, that's when the fans will go to full speed and ramp up. So again, maybe if anything, with some of this information that we can gather, it's also for just monitoring and seeing the performance, maybe not of the barn now or the sensors, but also the devices that we have in the barn. And again, you can see as temperature goes down, the fans actually, decrease in RPM as expected. So it's a simple concept that I wanted to show, but again, I think the point I'm bringing to to discuss is that there's a lot of data around the farm. It's just showing, and the important thing is not so much as the collection of data, it's how we use it. And I know we hear that a lot, but it is a really important thing to keep in mind. This is another, again, when we talk about the barn performance, this is another one I thought was rather interesting. So this is actually, this is from a robot barn in Wisconsin. And so you can actually see here, we can, not only can we graph out the average temperature, but we can also graph out the temperatures of the individual sensors. And so we have up on the top there, you have all the sensors there, the temperature sensors. The one in red is the average of all of them. And then you could see that the bottom one with the different, the different icon, the stars there, is actually the temperature. And I wanted to show this because I thought it was kind of neat. I know that obviously I took this yesterday, so we don't have all the information. But what I wanted to show here was that even though we're below freezing, you could see from the stars there, we're below freezing, we still keep the barn warm enough so that it's not freezing. So again, it kind of poses the question, and it's almost of old habit, when wintertime comes, we just turn the fans off. Well, should we do that, or should we keep some fans on, for ventilation purposes, for, again, let's say even in terms of for freezing, in this case, we're keeping the barn warm enough for the most part, that the barn isn't freezing. There's not icing, there's not icing up, cows aren't sliding, things like that. So I think it's really important to then note, this takes data that we collected to really look at it in a practical sense, and how we want to deal with the metrics that we have available to us. So as I alluded to before, and this is just a snapshot, but what this does is this allows us then to make those changes, and we make them in real time. So in the event in which we need to change the set points of a certain device, it could be, in this case, this is just highlighting circulating fans in a barn. And you can see the different pieces that you have control over. Again, it really adds a lot of flexibility in terms of, how we want to share things, or sorry, how we want to show the actual, the information that we have and the changes that we want to make. So I think that in this case, it's really important to note that, we can make those changes real time. And with that being said, it takes us to more of a proactive rather than reactive, as I mentioned. So again, this is, and it's also used by anyone on the farm. So it's rather encouraging, so that things aren't put off. You're spending less time doing barn checks. And even if that's something where you save 30 minutes to an hour, that's a lot of time, actually, when it adds all up and you do it every day. I used to do it. You'd be surprised. You can always find things to do in that extra time. So what's next? So I put this up here because this really kind of just shows really how much is really involved, how much actually, whether it's directly touches the cow, like water, air, feed, those kinds of things, as well as things that are maybe more abstract or not so much directly, incorporated, or, in the cow's life every day. But obviously, we have a lot of individuals, whether that's, on the education side, whether it's finance, all these things are all eventually tied down to that center. And so that's the important part. And so, if we can take care of those first things there, and the things that mainly touch the cow, through the things that are so much on the outside, like the sensors and how we ventilate and different things like that, then it really, again, gives us more information, more power to make better decisions, and find ways in which we can improve. So the one part that's next, so I wanted to just, again, come back to the idea with Allflex. So the next part of the data that we've collected, so that heavy breeding values that we're getting, I should mention that we do have the proof of concept set up in 2 farms. One's in Wisconsin, one's in Indiana. And again, to collect this data, to look at this over the, the environmental metrics that we have today, to tie the actual significant meaning to them. And again, as I mentioned earlier, to control the fans, how are we going to do that? And then now looking at maybe different things. So again, that's the ventilation aspect could be one thing. And, obviously that part of ventilation relating to heat stress, but also the barn temperature as it relates to rumination, for example, in different cow activity. So, more activity, I said more cow activity correlated to changes in the barn environment. So again, can we, there's some systems out there that have GPS or that have kind of a live feed of where the cows are, kind of on a map perspective. And the idea is not to actually gather, basically surface that into our program. But what would be interesting is to look at that in terms of what we have for mappings, and to see what percentage of a certain area cows are, kind of migrating to, especially depending on where the sun hits in the summertime. Are we bunching in certain areas? Can we kind of look at, and log that historical track of where that cow is, and see what do we have for ventilation, and maybe some of the changes that we could make so that we prevent certain things. In this case, let's say cow bunching, let's say things in which cows are, close together, giving up body heat in order, in this case, let's say maybe elevating heat stress quickly. So different things like that. So that's the next phase of this integration with Allflex, is to continue to collect the information, and then ultimately this summer, but more so spring, to actually look at it and have it available to actually see the changes in cow behavior directly from the cow, and have this as a modifier for changing fans or changing fan speed or performance. So I have this here, this map I actually pulled from the program as well. And again, it kind of tied to what I just previously said in terms of, what we can surface. So, whether that's, in this case here, dairymen tend to be very visual, and I'm the same way. And so, can we visually see everything we have on a map? Can we see the performance? Like, meaning, is everything okay? Are we green today? Okay, we're good. We don't have to investigate further. Is this, if something's red, if there's an alarm, let's see what it is and vet it to the people that need it, or that need to take care of the issue. So with this map right now, as it stands, we have the basic ability to map the pens that you see from the rectangles with the numbers. So those are the pens. These are 4 fan groups indicated by the different shade of purple or pink, whatever color you want to say it is. And these are circulating fans. So again, that's just one element that's showing us the devices that we have available. But again, the next part on this would be is, let's look, for example, at a heat map. And this could be in terms of the temperature operating speeds for the fans. Again, can we assess cow behavior? So, where cows are kind of mediating and congregating, can we look at that on a map? Again, maybe not so much the actual activity of where they actually are, but kind of use it in terms of how we want to monitor or assess the barn itself. And then venture down to more of like a 3D look, a little bit more maybe user-friendly, but at the same time, the point of this is that gets what we want to accomplish at least first, where we can see things, we can see activity, behavior, and then take it to the next level. And then some other new integrations aside from, so, the main one being with Allflex, again, as it relates to what we have today. But again, that only answers maybe a part of the question. We look at the profitability of cows today. It doesn't in efficiency of cows today. It doesn't all reside in one place. It's not just ventilation. It's not just parlor. It's not just your feeding regimen. There's so many different things, and again, all of these things collectively coming together. Really, again, those small wins that can improve on these different sectors, and hopefully overall, it does become a big win. So, with that being said, bringing in different herd information from the herd softwares out there. So, can we look at different correlations with the environmental conditions? Can we actually look at, for example, airflow as it relates to mastitis events. Depending on the way in which you're bedding barns today, maybe the bedding isn't getting dry enough and we're having more mastitis cases. Just things like that that we can really tie to with herd data, the influx of herd data. Same thing. My previous life was feed. I'm a feed guy, so looking at intakes with rain events, let's say changes in weather. We didn't quite have it in the last the feeding program that I worked with, but it'd be really nice to have these things readily available. There may be farms that do something, that might do something, but at least have it readily available from a program that actually does the number crunching, that actually does the visualizations, so that you spend less time in Excel documents and things and collecting information and spending time where it matters. And then cow activity. So again, as it relates to respiration, rumination, different things like that. And then really to the whole focus in which, our system is built is more so on the actual control side. But then obviously giving it much more intelligence, from the stuff above. But again, looking at what we have for metering water, metering electric, again, all of these things, for example, water could have a lot to do with cow cooling. How much water are we using to cool cows in the summer? So different things like that. So all this kind of ties to the bigger picture that we're trying to answer today. And I think that this will help make us successful, and more importantly, the dairies more successful, so that they can pass those savings on to other things that's needed. So that's really what I had for today in terms of the data. So really what we did is we went over the data visualizations that we have right now for heat stress as it relates to the project we have with Allflex, kind of a look into the second part of this integration. So really ramping up, taking the information we have, tying correlations, then using it to control the actual fans would be the next step. And then again, utilizing the other sensors that we have, depending on your operation, whether it's just your standard temp humidity probes, or if there's more such as ammonia, wind speed, there's a bunch of different things. But again, you can see from some of the graphs that there's a lot that can actually be, that can be monitored and measured. And again, I know we hear this a lot, from other talks, but again, it's one of those things that we need to be able to measure it in order to monitor it, to make better decisions for tomorrow. So that's all I had, and thank you very much.
Thanks, Charlie. We did have a few questions come in. I know you did mention this, but can you go over again what is heavy breathing and how is it measured?
Yeah, so and that's a good question, and that's actually part of in which we're still figuring out in terms of how we're going to use it. So heavy breathing, it is a metric or a value that comes from Allflex. Some of it is a little bit more specific to Allflex, so we don't have insight to maybe all of it of what it actually is, but it's measured as it is a percent value. But really the idea, what we have, and what I think I mentioned it earlier, is that for us right now, it's more of an arbitrary value. And so what we need to look at it in terms of how we have for, the readings, whether that's inside, outside readings of sensors, study the THR, study the heavy breathing percent, and also find the correlation of what it actually means in terms of, what it is for THI, how it correlates to THI, the actual, the algorithm and the math behind it to actually constitutes what it is exactly. Like I said, I don't have that information today.
So since you mentioned Allflex, is that the only company we are integrating with to work with heavy breathing and cow activity data?
Yeah, good question. So no, it's certainly not there. I mean, Allflex is just one of them. It's one that we have a good relationship with, but there's many others out there that we have good relationships with as well. And so there will be other companies in which we integrate with, again, knowing that, there are, for example, there are several different herd softwares, there's several different feed softwares, and same things for cow activity rumination. So There are plans to work with others as well, actually in this upcoming year. So it's not just subject just to Allflex.
Great. Can the software give general recommendations for airspeed at cow level and the duration of soaking on and off according to the pHI level?
So
there is an example, but would you like that or no?
So that's a really good question. And so I guess from what I understand it, so the question is if we can actually, based on the information that we collect today, give recommendations, whether that's for what we have currently set or recommendations for like, let's say the future or for the next couple of days. Is that right?
Yes.
Yeah, so the information that we have collected today will allow us to do that. So we don't have, in terms of like notifications, that it'll say, hey, like based on XYZ, do this, or duration of soaking, those kinds of things. Right now, in terms of soaking and fogging, we have is more so just the system in which we tell, we tell the actual devices what to do. Next step in that is actually getting the feedback from it so that we can, so duration of how long they're on. We have that kind of, there's obviously programs that we have set as it works for Dairy Boss. We need to kind of get the physical data from those devices through whether that's metering the water that's expelled, whether that's the duration for each of time the cycle is on a certain pen. So we do kind of half of it right now. And then this year we'll be working on doing exactly that, where we collect the other half of that information. So, the actual water coming back and different things that we monitor to then make inferences or make, suggestions on how, we can maybe change it to be a little bit more efficient.
Are we able to control fans pen to pen?
So yeah, so I mean, I think, and ultimately this question is a little bit more geared towards when the installs are actually performed. So right now, how we have it, at least how I've seen it, we have today, they're more in a group level, and it depends on either whether it's you yourself as a producer, how you want the fans to be controlled. They can be on a pen level. They could be, depending on different staging for, let's say, exhaust. It may not be directly at certain pens. It may be kind of across the end wall of the barn, let's say. So maybe it's not exactly in a specific pen, but in terms of the actual ventilation itself, let's say the fans over the cows, you can definitely, depending on how you want it set up, and maybe this is help with consultants as well, can have it set by the pen level. We actually have some farms that are doing that. So yeah.
Okay, and this is kind of related to when you were showing the charts that kind of equated when the calf barns were being cleaned and the ammonia levels. Do we have anything about data before or after fan cleaning, since we know that proper maintenance of fans is very key?
Yeah, so again, that's a really good question, and I'll even add to that by saying, it's one of those, like, when we look at RPMs, let's say, of the fans, can we see them, are we expecting it to be at a certain RPM given these certain constraints, but it's not, so meaning, like, are we eventually getting to a point where the fan's dirty? Do we need to replace it? So to answer that question, it depends. One depends on the type of fan, whether VFD controlled, motor controlled, maybe there's it's not as sophisticated. So one, it depends on, if we can get information back. So it depends on the equipment. If we can meet those constraints, and we do have the equipment is able to send us the information back into the program, then yes, the idea, and that's what we'll be doing with the information or with the devices that we can collect information back, is to take that and put that in a maintenance log to actually see the differences between fan performance when there's been service done. And we can look at really in a holistic way, in which, whether it's performance, whether that's whatever touches that fan, whether that's just the operation, whether that's somebody doing some kind of work to the fan itself. Again, this is something that is on the roadmap for this year that will be completed this year. Again, we just need to kind of outline what device, so what particular hardware does it have the capabilities to send us the information back, and then just build the housing to have the maintenance, what I call maintenance module in the program. But that's exactly what we'll be doing.
Great. Will heat stress be known in real time versus after it has already occurred?
Yeah, so how it works today, we usually get it, I think from Allflex, we get it every 30 minutes. So in this case, it's pretty close, but it's not, in this case, real time. I think by working, there's some other things that we were working out. In this case, for example, I'll use Allflex because we're already doing integration. But the idea right now is there's some actual technical things that need to be done on both sides to hopefully make it as real time as possible. We look at cloud accessibility and what we have today, and obviously the sooner the better. And so, the information that we collect is 30 minutes later, but the idea hopefully would be able to improve on that to make it more real time. Maybe it's a couple minutes off, but again, sooner rather than later, obviously, is always the best thing.
Got it. I believe this is probably our last question, unless any more come through, but who has access to all the reports that you showed today?
Yeah, so that's another really good question. So the reports, there's a couple things about the reports. They can be built by anybody that has access on the dashboard. So the reports here, most of them are built by myself, some others by other individuals on the team. Again, the nice thing about all the data that's collected is that you can make your own graphs. You can set your own constraints, different things like that. You can manipulate the graphs to export to CSV or PDF or whatever it may be. But then on the other part of that, as we onboard new customers, we also have 3 basic reports. And we start with those basic reports, and as time goes on and maybe we get more sophisticated or have more features or options, what we'll do is we'll just build up that library and add more to it, because there's some things that like, for example, there's some things that I don't know that I go to my colleagues and say, well, what should I know about this, and what should we have here? And so I think at the same time we also have to do our due diligence and provide provide that service to the customers to say, hey, these are what you should be looking at as well. So it's kind of a flexible thing in which we'd like it that you can build your own thing, but at the same time, we don't want to leave you high and dry either. We also want to be able to help you all, every step of the way. So
one other question did come through. When realistically will a cow or a small group have individual climate control?
That's a good question. I mean, I said all of them are good questions, but they are. Yeah, I mean, I think that some of this may be answered with more individualized. I think it really more so comes from the actual companies, like, for example, Allflex or NeedApp or whatever it may be. I think that it starts there. We a lot for what we have today in Dairy Boss and even some of the cow controls, a lot of it is kind of visualized at the group level, but we also know that there's a lot of, with all these informations and with these sensors, there's a lot of information on the group level. And so I guess to answer that, I would also say is we look at the practicality of, how, do we really want to control it by the individual animal based on what the devices we have around there? Is it good to do it by the individual animal? Is it good that is it better to have it on, more of a, to have it more on a group level? So it's definitely something of really, I think, high interest. I just don't know realistically. I don't think it would be this year, but I think that hopefully what we do, for this year in terms of group level stuff will hopefully set us up for individual cow metering, as mentioned. So not really probably anytime soon, but it seems like it would be a really cool thing to do.
Wonderful. Well, I think that is the end of our questions. So I think we're good to end this here. And thank you so much, Charlie, for your time today. And thank you, everyone,